Shah, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to start a new topic named improper integrals, right? So let us begin with the first topic, that is improper integrals, right? So the integral a to b f of x dx is called an improper integral if one or both the limits of integration are infinite, or if the function f of x becomes infinite at a point within or at the endpoints of the interval of integration, right? So in all, there are total 3 types of improper integrals, right? So let us start with the first type, right? So the integral a to b f of x dx is called an improper integral of type 1 if either lower limit or upper limit or both are infinite, right? So let us see the examples of improper integrals of type 1. So here you can see integration minus infinity to b 1 upon 1 plus x square dx. So our lower limit is infinite, right? Next, integration a to infinity 1 upon 4 plus x square dx. So here the upper limit is infinite. And the last example is integration minus infinity to plus infinity 1 upon a square plus x square dx. So here both the limits are infinite, right? So whenever you see infinity in the upper limit or lower limit or at both the places, then such type of integrals are known as improper integrals of type 1, right? Next, let us study improper integrals of type 2, right? So it is a definite integral in which the integrand becomes infinite at one or more points within or at the endpoints of the interval of integration, right? So let us study these using examples. So the first example is integration 0 to 1, 1 upon x dx. So here the interval is 0 to 1, right? And the function is 1 upon x, right? So this function is undefined, right? At x is equals to 0, okay? So this is integral of type 2. Next, here the given interval is minus 2 to 2 and our function is 1 upon x square minus 1, right? So this integral becomes undefined at x is equals to plus or minus 1, right? Suppose if you put minus 1 or plus 1, here it will become 1 upon 0 which goes to infinity, okay? And the last example is integration 0 to 4, 1 upon square root of x minus 4 dx, right? So here the interval is 0 to 4, okay? So the integral becomes undefined at x is equals to 4, right? So this integral becomes undefined at upper limit. This becomes undefined at some point in the interval. And this integral becomes undefined at our upper limit x is equals to 4, right? So these integrals are of the type 2. And lastly, let us study improper integrals of type 3, right? So it is a definite integral in which one or both limits of integrals are infinite and the integrand becomes infinite at one or more points within or at the end points of the interval of integration, right? So the first point up to here says that this is an integral of type 1 and this point suggests that it is an integral of type 2, right? So in all, what we can say, it is a combination of improper integrals of type 1 and type 2. Okay, so now let us see one example. So integration 0 to infinity 1 upon x square dx, right? So you can see infinity here. So the integral is of type 1 and here the function is undefined at x is equals to 0, right? So you can see that our integral is of type 2 also, right? So the given integral is of type 3, right? So now let us study few examples based on this. So here we have to evaluate integration 0 to infinity 1 upon x square plus 1 dx. Okay. Now here we can see we have infinity in our upper limit, right? So the given integral is an improper integral of type 1. Okay. So now let us study the method to evaluate such type of integral. So here we are given integration 0 to infinity 1 upon x square plus 1 dx, right? Now whenever you see infinity, right, you have to assume it as t. So limit t tends to infinity, integration 0 to t 1 upon x square plus 1 dx. Now we know the formula of integration of 1 upon x square plus a square dx, that is given by 1 upon a tan x upon a, right? So here this integral will become what? Tan inverse x, and the limits are 0 to t. Now let us put the limits. So limit t tends to infinity. First put upper limit in place of x, so you will get tan inverse t, minus put the lower limit, so you will get tan inverse 0. But we know the value of tan inverse 0, that will be equal to what? 0. Now if you put t tends to infinity over here, right, what you will get? Tan inverse infinity, and the value is what? Pi by 2, right? So our final answer is what? Pi by 2. Okay. Now let us study one more example. Here we have to evaluate integration 0 to 3 1 upon square root 9 minus x square dx, right? So here you can see that our integral is undefined at x is equals to 3, right? So the given integral is undefined at x is equal to 3. Therefore, what we can say, that it is an improper integral of type 2. Okay. So now let us see the method to evaluate such type of integral. Okay. So we are given integration 0 to 3 1 upon square root 9 minus x square, right? Now the integral is unbounded at x is equals to 3. So wherever the improper integral of type 2 is unbounded, we have to assume it as t, right? So what we will write? Limit t tends to 3, integration 0 to t 1 upon square root 9 minus x square dx. Okay. Now we know the formula. Integration of 1 upon square root a square minus a square is equals to what? Sine inverse x upon a. So using this formula, what we will get? Limit t tends to 3, sine inverse x upon 3, 0 to t. Now let us put our limits of integration. So what we will get? Limit t tends to 3, sine inverse t by 3 minus sine inverse 0. Now we know the value of sine inverse 0, it is 0. And here if we put the limit, what we will get? Sine inverse 3 upon 3, right? So we will get sine inverse 1, and the value is what? Pi by 2. So the answer of this improper integral is what? Pi by 2. Okay. Now let us study one more example. We have to evaluate integration 0 to infinity 1 upon x square dx. Okay. So let us start with the solution. So here you can see we have infinity in the upper limit, and also the function is undefined at x is equals to 0, right? So here the given integral is an improper integral of type 3. Okay. So now the upper limit of the integral is infinite, and it is unbounded at x is equal to 0, right? So we will separate our given integral in two parts, that is we will convert it into integration 0 to 1 1 upon x square dx plus integration 1 to infinity 1 upon x square dx, right? So this will be of type 2 and this will be of type 1. Okay. So firstly let us evaluate our I1, that is integration 0 to 1 1 upon x square dx, right? Here the integral is undefined at 0. So what we will assume it as c1. So limit c1 tends to 0, integration c1 to 1 upon x square dx, right? So now the integration of this term will be what? Minus 1 upon x, and the limits of integration are c1 to 1. Okay, so now let us put the limits of integration. So if you put 1 in place of x, the resultant answer will be -1, plus if you put c1, then it will be 1 upon c1, right? Now suppose if you put the limit, right, then here 1 upon c1 will go to infinity, right? So the resulting answer of I1 is what? Infinity, right? Now we have to evaluate this integral and we'll assume it as I2, that is equals to integration 1 to infinity 1 upon x square dx. So this is of type 1, right? So we have to assume infinity as C2, right? So limit C2 tends to infinity, integration 1 to C2 1 upon x square dx. Now integrate this. So what you will get? Limit C2 tends to infinity minus 1 upon x, and the limits of integration are 1 to C2. Now put these limits over here. So what you will get? Limit C2 tends to infinity minus 1 upon C2 plus 1. Now here if you put infinity, 1 upon infinity will give us answer 0. So 0 plus 1. So final answer is 1. Right? Now we have to find the answer of I. But I is what? I1 plus I2. But our I1 is infinite and the answer of I2 is what? Finite. But the total answer will be what? Infinite. Okay. So we have evaluated the improper integral of type 3. Okay. Now let us study direct comparison test. We are studying this test to check the convergence of improper integrals, right? If f of x and g of x are two continuous functions for x greater than equal to a, such that 0 less or equals to f of x less or equals to g of x, then integration a to infinity f of x dx converges if integration a to infinity g of x dx converges, right? If we have this condition, then if g of x converges, then f of x also converges, and integration a to infinity f of x dx will be less or equals to integration a to infinity g of x dx, right? And the next condition is if f of x and g of x are two continuous functions for x greater than equal to a, such that f of x greater than equals to g of x, then integration a to infinity f of x dx diverges, right? If integration a to infinity g of x dx diverges. So if the integral having g of x diverges, then the integral having f of x also diverges, right? Next, let us study one more test, that is limit comparison test. Okay. So if f of x and g of x are two continuous functions for x greater than or equals to a, such that f of x and g of x both are greater than 0, and limit x tends to infinity f of x upon g of x is equals to L, where 0 less than L less than infinity, that is the value of L should be finite and non-zero, then the integral a to infinity f of x dx and improper integral a to infinity g of x dx both converge or diverge together simultaneously. That is, firstly we have to check the limit of this, right? It should be finite and non-zero. Then only what we can say that both the improper integrals converge or diverge together, right? So now let us study few examples. So we have to test the convergence of the improper integral 1 to infinity cos x upon x square dx, right? So in this we will apply our direct comparison test. So let us start with the solution, right? So here our f of x is cos x upon x square. So we will assume our g of x as 1 upon x square, right? Why we are assuming this? Because we know that cos x is less or equals to 1. So if we divide by x square, what we will get? Cos x upon x square less or equals to 1 upon x square. Now this is our f of x and this is our g of x. So from this what we can say, f of x is less or equals to g of x. Okay. So now we'll check the convergence of g of x, right? So we will find integration 1 to infinity g of x dx. But what is our g of x? 1 upon x square, right? So let us evaluate this integral. But this integral is of type 1. So we have to assume this as b, right? So limit b tends to infinity, integration 1 to b, 1 upon x square dx. Now evaluate this integration. So what we will get? Limit b tends to infinity minus 1 upon x. Write the limits of integration. They are 1 to b. Now put the limits. So you will get limit b tends to infinity minus 1 upon b plus 1. Now suppose if you put infinity, right, this will go to 0. So our final answer of integration will be 1, which is a finite answer, right? Therefore, what we can say that our given integration of gx, that is integration 1 to infinity 1 upon x square dx is convergent, right? So now by direct comparison test, we can say that our integration 1 to infinity cos x upon x square dx is also convergent. Okay. Next, let us study one more example. So we have to check the convergence of integration 4 to infinity 3x plus 5 upon x raised to 4 plus 7 dx. Okay. So in this we will apply our limit comparison test. Okay. So let us start with the solution. So we are given our f of x as 3x plus 5 upon x raised to 4 plus 7, right? And we are assuming our g of x as 1 upon x cube. How we have found out our g of x? So firstly write your f of x, that is 3x plus 5 upon x raised to 4 plus 7, right? Now take out x common from the numerator. So what you will get? 3 plus 5 upon x, and take out x raised to 4 common from the denominator. So you will get 1 plus 7 upon x raised to 4. 1x will get cancelled out. So what will remain? 1 upon x cube. So we are assuming our g of x as 1 upon x cube, right? So now let us find our limit of f of x upon g of x. So put your f of x, put your g of x and simplify, right? So put this also. So finally these two will get cancelled out. What will remain? 3 plus 5 upon x upon 1 plus 7 upon x raised to 4. Now as x goes to infinity, these two will go to 0. So what will be the final answer of the limit? It will be equals to 3, which is finite and non-zero, right? So now from this we can say that if the g of x, that is integration 4 to infinity g of x is convergent, then our f of x will also be convergent, right? So we will evaluate this integral, that is integral 4 to infinity g of x dx. Put the value of g of x, that is 1 upon x cube dx, right? Now this integral is also of type 1, so we will assume our infinity as b. So limit b tends to infinity, integration 4 to b 1 upon x cube dx. Now find the answer of integration. So what we will get? Limit b tends to infinity minus 1 upon 2x square, and your limits of integration are 4 to b. Now put this limit. So what you will get? Limit b tends to infinity minus 1 upon 2b square plus 1 upon 32. Now whenever you put b tends to infinity, this will go to 0, right? So our answer of integral is what? 1 upon 32, which is a finite answer, right? So from this what we can say? That our integration 4 to infinity 1 upon x cube dx is convergent, right? Therefore by limit comparison test, integration 4 to infinity 3x plus 5 upon x raised to 4 plus 7 dx is also convergent, right? So I hope you have understood throughout the session. Thank you for watching.